starting chapter 7, we're going to break up the sections in this chapter a little bit differently. I teach factoring a certain way and others teach it a different way. This author goes about it just slightly different, which is great. You're going to get exposure to at least 2 different ways just by watching the video lessons and reading through the book. You might even have been exposed to a 3rd way or come across a 3rd or even 4th way to factor. But anyway, you'll notice that I break up chapter 7 just a little bit differently than the book has it. So we're going to start in 7.1, but we're only going to do the first part. We're only going to focus on the greatest common factor. We'll come back to the second part of 7.1 in our next lesson. But let's start talking about factoring in general. The rules of algebra are there because they're based on the patterns that we see with numbers. In other words, what works with numbers also works with algebra, because all algebra is some of the numbers are covered up by letters or missing or unknown, and we replace them with letters. So if it works with numbers, it has to work with algebra as well. The same is true for factoring. Factoring is a way you break something down into two or more things being multiplied to get you back to the original. Now let's look at, say, a number like 13. If we tried to break this down into 2 things being multiplied together, the only thing we can break it down to is 1 times 13 equals 13. We call this a prime number because there is no other number besides 1 in itself that it can be broken down into. So prime number, meaning only 1 in itself can go into it. If you try to break it down into multiplication, you don't get anywhere. Then you take a number like 10, and there's lots of ways you could break this down. Well, I'm sorry, there's not lots of ways you could break this down. There is a way to break this down. It can be 1 in 10, but that doesn't really get you anywhere. So 2 times 5 is a way to break this down, and 2 times 5 is now known as its prime factorization, because now every number that you've broken it down into is a prime number. So 2 times 5 is representative of 10 as its prime factorization. When you're talking about algebra, one of the things we want to find, and when we're factoring, we want to look for the GCF, okay? And that stands for the greatest common factor. So in terms of algebra, when we're looking for a GCF, which is going to be our first rule of factoring, it's going to be the first thing we always check for. What we're looking for is something that can be multiplied by, in each situation, some sort of factor that they have in common. Both are the same in each term, and it's the largest that they have in common, the greatest common factor. Now let's take that number 10, because what works with numbers works in the algebra. So here's how greatest common factor works, and let's look at it with numbers first, and then we'll look at it with the algebra. Let's say we had that number 10, and we said, okay, one way you can get to 10 is if you take 2 plus 8. That's a way to get to 10. Now you have 2 terms. Added together equals 10. So just a little shorthand there, added together equals 10. And what we're looking for is the greatest common factor. What do both of these terms have in common? Both terms have a factor of 2 in common. In fact, that's the biggest thing they have in common, because this first 2 can be written as 2 times 1. A factor is what you can multiply something by, and this 8 has a factor of 2 if you multiply it by 4. So 2 times 1 is 2, 2 times 4 is 8. Now they both have a 2 in common. Okay, again, I'm just showing you what the numbers would do so you can understand why it works with the algebra. Now, when you're pulling out the greatest common factor, when you're factoring, what's happening is you're undoing the multiplication. So factoring is equal to undoing the multiplication, or in our case, the distribution. Well, it helps if I spell multiplication right, huh? Undoing the multiplication, or in our case, the distribution. So imagine that the step before this 2 being multiplied by both pieces, the 2 was out front. And in the case of numbers, we see that we can do this because order of operations tells us that that 1 plus 4 is really 2 times 5, and we're just back to 10. So I just want to show you with the numbers why you can go ahead and find something in common with two terms, a common factor, factor that out, undistribute it, undo that distribution. So the step before would have been the distribution, and we are undoing that distribution. And then order of operations shows that 2 times 5 is the same as 10. We're back where we started. This right here is just another way to write 10 using greatest common factor. And so that's what we're trying to do. And that's what these instructions will say. Factor each polynomial I'll just make another note here. Same value as we started with. So factoring doesn't change the value of anything, it just changed the look of it. We're just rearranging so we can see what the terms have in common. So it's the same value we started with. Factor each polynomial using the greatest common factor. I'll pause here because we need to adjust the page.